Good morning. This recording is for Pre-Algebra Chapter 10, Lesson 6, Surface Area of Pyramids, Cones, and Spheres. So a lot of this is just remembering what shapes make up your nets of a space figure and then figuring out the area of those. So they do have some very complicated formulas that can help you with this, but we're going to break it down into basic shapes. So if you just remember that a pyramid is made up normally of a quadrilateral and triangles that cover the perimeter of it, you're going to remember that the area of a pyramid is 1/2 base times height, and then you just need to find out the area of the base. So that's what we're really going to do. The other thing that you need to know about pyramids and cones is that they have what's called a slant height. And a slant height is basically the edge or the distance from the bottom of the pyramid to the top of the pyramid. So right there, those highlighted parts, those are all the slant heights, and it will always be at a right angle to in your textbook for the pyramids. Okay, so look for that right angle along the lateral face or along the lateral faces of your pyramids, because that's going to be your slant height, and the slant height is also the height of the triangles that make up the lateral faces of your pyramids. So, and then the big B down here is the area of the base. So you need to figure out what the lateral surface area is, and then you need to figure out what the area of the base is, and that will give you the total surface area of your pyramid. And then they use perimeter, but again, like I was saying, we're going to figure out the area of all of the triangles of the pyramid, which is 1/2 base times height, where the length is the slant height. So you could use H instead of L here, but they're going to use L probably every time in your textbook, so just be aware of that. And then B is the base of the triangle, not to be confused with the big B, which is the area of the base. All right, so that is the side length, which is basically right here. So that's just the side length. Okay, is the little b. All right, and then we're going to do that times 4 because we have 4 triangles, and then we're going to add the area of the base, which is right there. All right, so let's go ahead and practice this using some information about a pyramid. So a pyramid has a square base. Well, that means it looks like this. And the edges are 20 feet, which means the area of the whole base is 20 times 20, which is 400 feet squared. Now the slant height, now see how I basically made this figure right here, right there? That's what I've made there, but it's with the dimensions that are given to me in the problem. Okay, so the slant height is 8 feet, which means from the base to the tip or the vertex of my pyramid is 8 feet. Now I have 4 of those triangles, and the triangle has a base of 20 and a height of 8. So if I go ahead and figure out the area of one of my lateral faces, it's 1/2 base times height, which is 20 times 8, and I'm going to get 80 feet squared. But I have 4 of these triangles. So it's the area of one triangle, so if I multiply it by 4, because I have 4 of them, I'm going to get the area of all 4 of them. Then what I'm going to do is I'm going to add the area of the base and the area of the lateral faces to get the total surface area of my pyramid. Pretty cool, huh? All right, so the total surface area of my pyramid is 720 feet squared. And don't forget about that feet squared. You're dealing with area, so it should be your unit, in this case feet, and then squared. All right, let's go ahead and talk about cones. So cones are pretty cool. If you look at the net of a cone, the lateral face is actually pretty much a triangle. And let me show that to you again. So see, well, yeah. So right there, see that triangle that I made? That triangle that I made right there? That is the lateral face. And just like a triangle, the area is the base times the height, but the height, again, is the slant height, which in this case is still L. All right? Still L. So we're going to find the area of the lateral face, or the lateral area, and we're going to add the area of the base, which is that. So if I want to find the area of the lateral area, I need to use the triangular formula, which is the height of the triangle, that is the lateral face, is the slant height. All right, so that would be L in this case. And then the base of the lateral area, that is the surface area, is the circumference. And I spell circumference wrong twice. It's E-N-C-E, not A-N-C-E at the end. Okay? So, again, the bottom of this triangle that makes up the lateral area is the circumference of the circle of the base, and the height is the slant height. All right? And then again, don't forget big B means the area of the base. In this case, is a circle. So let's go ahead and, oh, you can ignore that, actually. I wrote over myself and didn't realize it. Okay, so let's go ahead and use this information. So we have a cone that has a slant height of 39 feet and a radius of 7 feet. We need to find the surface areas to the nearest square foot. So here's my net. I have a triangle that makes up the lateral face, and I have a circle that makes up the base. So the area of the lateral face is 1/2 base times height, where the circumference is the base, basically from here to here. That's the circumference, because you got to think about it. It would be the distance around the circle, because it's going to go all the way around it. And that's the circumference, which is also known as the base. And the slant height is right there, which is basically how high the triangle is. So there we go. We can use this information to find the area of the lateral face. So the circumference is 2 times pi r. So it's going to be 1/2, 2 times pi r, r being 7 in this case, which is the radius, times the slant height, which is 39 feet. So if I find the circumference and then multiply it by the slant height times 1/2, I'm going to get the lateral area, which is 857.22 feet squared. All right, but now we also need to find the area of the base. We found the area of this triangle right here and got that. But now we need to find the area of the base, which is the circle right here. Well, how do you find the area of a circle? Well, that's pi r squared. So we're going to use 3.14 for pi. The r is radius squared, so that would be 7 times 7, which is 49. So 3.14 times 49 is 153.86 feet squared. So now we need to add the area of the lateral face and the area of the base. Put them together, and we get the surface area of 111.08 feet squared. But since they want us to round to the nearest square foot, that's 1,011 square feet. All right, now let's talk about the area of a sphere. Now this is just a formula you need to memorize, that a sphere has the same area as 4 circles with the same radius. So you're going to find the area of a circle with the radius given and then multiply it times 4. Pretty easy. So pi r squared times 4. That's how you find the surface area of a sphere. Just memorize it, guys, and just remember that the surface area is the area of a circle times 4. Okay? So let's go ahead and put this into practice. We have a sphere with a radius of 6 centimeters. We're going to find the surface area. Well, it's 4 times pi times r squared. Well, r in this case is 6, so it's going to be 4 times 3.14 times 6 squared. 6 squared is 36, because remember, PEMDAS, you need to do the exponents before you do the multiplication. So it's going to be 4 times 3.14 times 36, which is going to give me a whopping 452.16 centimeters squared, which is the surface area of a sphere with the given dimensions. All right, I'm done, guys. Hope you enjoyed this short video. Bye.